Welcome to 3.2. Let's play with some absolute values and inequalities. What could be greater? All right, we are starting off with some absolute values. So you should kind of be familiar with the little brackets for absolute values, but just so you know, absolute values, looks like this, equals absolute value of x. And the graph is kind of the more important part. That's where we're kind of learning. Hopefully you remember that it looks something like this. It is a V and it turns at this point right there. And that is called the vertex. So if we look down here, the graph looks like a V and the turning point is called a vertex. So those are kind of some important parts right there. So how did I come up with that V? I just kind of knew it off the top of my head, but more importantly, we used this age-old trick right here, and that is a glorified version of guess and check. So we made a chart of a couple of really strategically good or just random x values, and we found the y values that corresponded with them, and we plotted it on a chart. So if we were to look at this, I'm going to do it in blue. So we've got our vertex at 0, 0. So if I were to plug in 0, by the way, our function that we're looking at is f of x equals just the absolute value of x. Rewriting it just so that we can see it. So we plug 0 in for x, we get 0. Okay, we plug 1 in for x, we get 1. We plug 2 in for x, we get 2. And 3. Okay, hopefully you're noticing a pattern here. So let's go into the negative sides. We plug a negative 1 in for x, we get positive 1. We plug a negative 2 in for x, we get positive 2 and 3, and so on and so forth. So for starters, we'll learn a little bit better, like how to graph them, find the vertex, things like that. But for starters, any graph in the world, if you find yourself on a test and you forget how to graph, throw some x values at it, find the corresponding y values, plot them on the graph, and you're good to go. So if I were to plot these, I got 0, 0 right here, 1, 1, 2, 2, 3, 3, negative 1, 1, negative 2, 2, negative 3, 3. And that's where the graph comes from. So talk about our domain. We look at all of our x values that cross the line. These arrows go on forever. So our domain is going to be all real numbers. So our range is a little bit more interesting, but our range in general starts here and goes all the way up because we can cross the line there and there and there and there. It crosses twice even. But either way, so our range is going to be y such that y is greater than or equal to 0 at this point. And that's generally how you graph an absolute value. Okay, so there's just the normal random guess and check where you randomly throw x values, but we should probably be a little bit more strategic about it, right? So here we are, here's some good hints. So number 1, find the x value of the vertex. And the way you do that is by you set the expression from inside the absolute value, inside the bars, equal to 0, and then solve. So that's down here, that would be just this little part, the things inside of the absolute value. So then place the value in the middle of your row of your table, throw some numbers up, throw some numbers down, and then graph. So in general, these examples, they make you do a lot more than you really need to. So I'm going to show you how much I want. You can do as much as you want, but at least hit my minimum. Okay. It said step number 1, find the x value of the vertex by setting the inside of it equal to 0. So if I were to do that here, x minus 4 equals 0. So my x value for my vertex is going to equal 4. So we're going to put 4 in the middle. And at minimum, you need, let's say, 2 values going up, 2 values going down. You could kind of do it with 1, but just to make sure, let's do 2. So I'm going to say going down 2, so that would be 3, 2, and then we'll go up some, 5, 6. So now we're going to plug those into our equation, and we'll get some values. So if I put 4 in there, I'm going to get 0. If I put 3, 3 minus 4, it's going to be -1. Its absolute value turns to +1. 2 minus 4, it's going to be +2. And oh, hey, look, there's a pattern. So yeah, absolute value should be the same way. So our vertex is at x equals 4. 1, 2, 3, 4. And we've got 3, 1, 2, 2. We've got our 2 points there. And there we go. So our domain is going to get pretty easy after a while. Once you catch on to the pattern, it's going to be all real numbers again. Most absolute values are all real numbers. And we know that because we can pick any x that we want, and it does cross the absolute value at some point. And our range, it's going to start right there and go up. So we're going to say y such that y is greater than or equal to 0. So that's generally how you graph. Okay, here we go. We got lots of examples. So I'm going to kind of breeze through some of them and explain them as I go. So here we go. I took all of this, set it equal to 0. So our x just equals 0. So that's where my vertex is, and that's where this value starts. I went 1, 2, 1, 2 in both directions. I'm sorry, 1, 2, -1, -2. And that's where we got that. So we just draw my absolute value. So as we move down the row, once again, we took this thing. Oh wait, let's go back up. So just so you notice, look at this. We have a +5 that is on the outside of the absolute value. And look, 1, 2, 3, 4, 5. So the whole graph moved up 5 things. That's interesting. But as we move on, so here we've got an absolute value on the inside, a +1 on the inside, a negative sign on the outside. So let's see what happens. Set the inside equal to 0. My x equals -1. -1 plus 1 is 0. And get my values. Got my -1, -2, -3, 0, 1. And then here's my corresponding y values. So let's plot those. So we've got -1, 0. It moved to the left one when there was a plus on the inside. Interesting. Okay, but there's a negative sign on the outside. So what happens? So yeah, there's a negative sign on the outside of the absolute value. So that's where all of these negative signs come from. And that's okay. So -1, 0, -2, -1, -3, -2. So the whole graph moved 1 to the left and then flipped and is now facing down. I feel like this thing may have made the graph flip down. Interesting. And so I guess I've been forgetting the domain and range of these, but hey, the domain, oh, look at this. All real numbers. Here, let's go back up and do this one. All real numbers, good to go. So the range for up here, it starts right there and then goes up. So we're just gonna say y is greater than or equal to 1, 2, 3, 4, 5. So here we're gonna have y is less than or equal to 0 because the graph is going down. So number 7 is kind of more fun. It's that piecewise function. So you guys are gonna see this over and over again, and I've heard a lot of groans because, you know, they're not hard per se, there's just a lot more steps. So here we go. We've got, what have I done so far? So I started with this one right here because it's the absolute value. So that's kind of what we were talking about. So I made my boundary line right there, and I set the inside equal to 0. I've got x equals 3. So, and then when I put that in there, I get 3, 0 right there. So there's my vertex. Now, normally we go, a couple of numbers to the left and a couple of numbers to the right. Well, here, since this boundary is here and this absolute value, since it's on the bottom, it's on the right side. The only thing I care about is on this side of the vertex. So I'm not even going to bother with the left side. At this point, who cares about it? I don't. But we are going to go to the right. So let's see, that's 3. So 4, 1, 5, 2, and that's enough for me to make my line. Oh, I should have started here and gone up. So yes, there's another part of the absolute value that goes there, but again, because it's on the wrong side of that borderline, if you will, we don't care about it, so we're not going to draw it. So that's, let's see here, and that said greater than or equal to. There you go. So now we got to go back and do this one. So yes, I did it out of order. Just don't get lost there. But we've got, this is just a line. So we've got a y-intercept at 1. And then our slope is -2. So we're going to go down 2 over 1, down 2 over 1, down 2 over 1. And here we go. With this sign, this is going to be an open circle here. And we're going to draw this going up. That was a fantastic line that I made. You're welcome. So then from there, since it's piecewise, we probably do need to look a little bit closer at the domain and range. Domain is, again, our x values. So this is a line. We hit it all, but let's look at our border. Because this is a closed circle right there, our border is part of the domain. So we are still going to say all real numbers, but because it's piecewise, definitely double check that. So now when we look at our range, if we're going up, so it starts here, but it does not include that. That's a -7, and it just keeps going up. And here, yes, it crosses twice, but we honestly don't care. As long as it crosses at least once, it is part of our range. So our range, we're going to write y such that y is greater than -7. Greater than, because that is an open circle. So now that you're an expert at graphing absolute values, let's add one more component. So what happens if it is an inequality as well? So now we'll do the exact same thing that we did earlier. So we're gonna create a table of values, finding the vertex. You should probably find the vertex first. Then we'll graph. We're gonna use a dashed line for the less than or greater than, and then we're gonna use a solid line for the less than or equal to, or greater than or equal to symbols. And then we're going to shade. So assuming y is to the left, shade above the line, or greater than for greater than or equal to symbols, and below the line for less than or equal to symbols. Once we get into some examples, if you kind of think about it and logic it out, it becomes a little bit more obvious. But I'll show you a trick. If you just kind of need a mathematical formula that works every time, then I'll show you that as well. So if I'm looking at number 1, so I take x plus 1 equals 0. I get my x equals -1. So that's where we're going to start with our vertex. So when I plug -1 back in, we get 0. And then -2. -2 plus 1 is -1 equals +1. Then -3 goes back into x. -3 plus 1 is -2, absolute value +2, and it's going to go 1 and 2 down here. Then we've got our vertex, -1, 0, 0, 1, 1, 2, then go up here. Oh, look, we had that +1 on the inside and it moved to the left. Weird. Anyway, so we're gonna do this right. We're gonna look at that. That is a less than sign, meaning it does not have an equal to. So we're going to draw our dotted line. Now, I told you that there's two real good ways to figure out whether I should shave above or below. So if you want to kind of just logic it out, so if you just kind of look at it, so if you've got all of your y's have to be less than all of this. So if this function is this line, then your y's need to be less than that line, right? So that kind of makes sense if you logic it out. But if that logic doesn't make sense and you want just kind of a surefire, like, hey, what do I do to figure this out? I'll show you that on the next one. So down here with number 3, we're going to do the same thing. We're going to take the inside of here. We're going to set that equal to 0, and then do some algebra and, oh no, x equals a fraction. Ew, gross, right? It's fine. We'll put it in here, but I'm with you on this one. I don't want to do math with fractions. So that's why I chose -2, -3, and then -1, 0. So I just kind of went to the next whole number so that I didn't have to mess with the fractions over and over again. But anyway, so we plug 3 halves into there and we will get 0. So now we're going to plug -2 in. -2 times 4 is -8 plus 6. It's going to be -2. Then it's an absolute value, so that's going to be +2. So then -3 times 4 is -12 plus 6 is -6, and absolute value is +6. So all I did was plug these numbers into there. So then we're going to have 2 and 6 down here as well. And let's see here. So let's graph this. We've got -3 halves, which is like -1.5. Put a dot right there. And we've got -2, 2. -3, 1, 2, 3, 6. 1, 2, 3, 4, 5, 6. We'll do the same on this side. Looking at that symbol right there, that means it's going to be a dotted line. Try to make your dotted line straight. This time it didn't turn out that straight. Okay, so I told you I was going to give you kind of a surefire way to kind of test to see if you should shave up or down. So what you do is you pick any random point that you want, plug it into the equation, and see if it's a true or false statement. So I always pick a convenient number, which normally is the origin, because zeros are a little bit easier to do math with. So if we plug 0 in, we're going to have, for both x and y, because we are plugging this point in, we're going to have 0 is greater than 4 times x, well, I'll write it out, 4 times 0 plus 6. So then that is going to turn into, I'm coming down here, 0 is greater than 4 times 0 is 0 plus 6 is 6. So is that a true or false statement? 0 is greater than 6. That is definitely a false statement. That means that this point, being the origin, is not in the shaded region. So we know that this is where we will shade. Either strategy works. Thinking it through or using a test point, both of them work. As long as it works for you, that's the important part. So last but not least, we got number 5. This one's a little bit more complicated, which is why I wanted to do it. So we started the same way though. We look at what's inside the absolute value and we set it equal to 0. We do our algebra and we find that x equals 6. So we added my 12 to both sides, divided by 2 to both sides, and that's where we got x equals 6. So that's where we're going to start with our vertex. So now we just plug that 6 into our equation. So 6 times 2 is 12 minus 12, so that's 0 minus 7. That's where our minus 7 comes from. So now we're going to take 5 times 2 is 10 minus 12. We've got negative 2, but that's inside of the absolute value, so it turns into positive 2. Positive 2 minus 7 is negative 5. Okay, so let's do 4. So we take 4 times 2, which is 8, minus 12 is a negative 4. Yeah. In absolute value, turns to positive 4, minus 7, turns into negative 3. And because I know absolute values, I know those are going to be our values over there too. Okay, so let's graph that out. 6, negative 7, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So when we went to 7, negative 5, 1, 2, 3, 4, 5. And then over here, negative 3, 1, 2, 3. Looking at this guy right here, that is a greater than or equal to sign. So that means we can do a solid line. Those are way easier to draw too. So now we got to look at our shading. So again, you can either take a test point like 0, 0, shove it in, see if it works, or you can kind of logic it out. So if I say y is greater than or equal to all of this stuff, that means that we would be shading on the top. So that's in general how you graph absolute values and how you graph absolute values inequalities. So here you go. It's your turn. I'll see you in class.